Testing, testing. 1, 2, 3. Testing, testing. How's everybody doing today? Anybody got a test today? So, I guess we might as well get started then. Last time we were talking about databases, and we were going over some of the primary, most simple operations that one can perform on databases, such as creating them, putting things into them, and getting stuff back out again. So, let's just load up our SQLite 3 command prompt and open back up the database that we were working on last time. .open movie store.db. So, pardon me. So, and I apologize, I can't really make this bigger because this is a command prompt. So I guess you're, well, maybe I have a magnifier or something. Ah, there, that'll do. So, with respect, there we go. So with respect to our movie store database, let's review very quickly how it is that you display information that's in a database. Well, you use the select keyword. Select star from movies will return all fields from the table movies within the database that you're working on. Remember, databases are organized into tables, fields, and records. If you're using a spreadsheet analogy, a table in a database is very similar to a sheet in something like Microsoft Excel. The rows in Excel are the records in a database, and the fields in a database are the columns in the spreadsheet. So let's select all from movies, and semicolon. So you can see we have a somewhat incomplete list of the movies that were provided within the slides. Good. So, if you wish to view only specific fields from movies, then you would select, for example, title and rating from movies. That'll give you the list that's filtered out all of the things that you haven't asked for. So, there are 4 things that you have to specify when you are trying to get data out of a table. Number 1, the fields that you wish to return. Number 2, which table you wish to return them from. Number 3, which rows you wish to select. And number 4, the order in which you sort them. Put you there. So, it is possible in structured query language to filter the results that we get from our selection even further by the use of Boolean statements. So, in this particular instance, what if we wanted only those movies that had a PG rating? Well, if we go back to our command prompt, we go select star from movies, where is the keyword that indicates we're creating a conditional statement, where rating equals PG. And we get both PG things from this list. There's also a like operator that returns things that contain strings. So these percent signs inserted into the string are in fact wildcard matching in the same way that star is wildcard matching, which you've probably seen star used as wildcard matching in the past. So, if we want all of the elements in here in the database that, for example, contain the comedy tag in the genre, for example, we say where genre like, and we'll do comedy. Where genre, oh my. Well, this is interesting. Can I leave that like that? What the heck is going on here? Sorry about this, folks. I think I've moved the toolbar up and okay, let's just kill the magnifier then. Okay. Oh my god, come on. Sorry about that, folks. Good lord. So, where were we? Right. So, we use the like modifier to indicate you use it essentially in place of the equals operator, and it does this kind of fuzzy matching. And there you go. That's a list of all the comedies. So there's one other thing that you can apply to what is wildcard matching. That's a good question. Thank you. So when you are matching a string, you see this a lot in the Linux operating environment, where you may wish to apply some operation to all of the files of a particular file extension. So if you want to do something like that, let me just open up Notepad here for a moment. So if you wanted to select everything in a directory that was of type txt, you do star.txt. There we go. So this wildcard stands for any string. So basically, this would mean that, this.txt, that would be caught by this. That.txt would also be caught by this, but the other .mpeg would not be caught by this because the tail part doesn't match. So this is called a wildcard character. The reason lag, you say? So the reason it's called a wildcard is from it's a board game analogy from a game like Crazy Eights. So in the game Crazy Eights, which is a game you play with a standard deck of cards, but you have to do a lot of memorization, there is a card that can be any card you want it to be, and that is called the wild card. So when we have a character that can be any character or sequence of characters that we want, we can use it in a string to indicate this could be a lot of different things. That's called wildcard matching. So what we're doing in the example in SQL is we are using wildcard matching before and after the term comedy, so that and a wildcard can also be nothing, so it can be an empty string. So when we're matching on the field genre, if it has the text comedy anywhere inside of that text, then you're going to get a positive match on this wildcard matching. It doesn't matter if it's at the beginning or if it's at the end or if it's in the middle somewhere. If it's there, it'll be matched. Does that make sense? Hopefully. Good question. So, further to our things that we can do with the data that we're getting back, it's also useful to know how to sort the data. So we have a special operator for that in SQL. So let's select all from movies and order by. So order by is the key term that tells us that we are performing an ordering operation. We then have to specify which field we are ordering by. In this case, we'll order by title. And you can see we have gotten back all of our things in order of their title, where entry 402 does not have a title. Good. Excellent. So it's possible to order things using ascending or descending order. Ascending order is this one, which is the one that it does by default, and descending order is, of course, the other way around. Which, that should be reasonably, reasonable. So, this is all good, but let's try to link things back to Python specifically. So, Python has a library module which you can use to access SQLite 3 databases. The manner of interaction here is actually very similar to what we've already experienced with CSV files and JSON files. So the general procedure is that you need to open up the database and get a file handle for it, although our database handle is going to operate somewhat differently from our file handle that we have been using so far. Then we need to perform any operations that we wish to perform on the database, and then, of course, whenever we have a file handle, we have to close it when we're finished. So, pursuant to this, Python will automatically convert some of the regular data types of Python into SQL data types. So, if you have null in SQL, that's none in Python. Integer in SQL becomes int in Python. Real becomes float. Text becomes string. However, you got to watch for the last one because date does not translate into the Python datetime object or class that we were discussing in previous lectures. In fact, it is converted to a string. So, in order to have this date in SQL converted into a datetime object in Python, you're going to have to use a parsing method like the parsing methods that we used back in the slides that we dealt with, where we dealt with date as a class. So you're going to have to do a exterior conversion there in order to get everything to work. However, perfectly possible to get everything to work. You just need to know what format the date is coming out of SQL in, and you can determine that very easily by just asking it for some and seeing what it looks like. So this is how it works. The manner in which you interact with an SQL database in Python is using the same SQL queries that you were using if you were to be using them in a dedicated interface such as this one. However, the difference is, in Python, these SQL queries have to be formatted as strings. It's a string that you pass to a method. That method takes the string and interprets it as SQL commands. Once it has done that, it performs the operations that we wish to perform, and then it moves on with its life. So we have, and the other thing that we have to do is we have to open up a cursor. A cursor is a type of object that iterates over the SQL query. It iterates over the results of the SQL query. It's quite similar to the CSV reader or dict reader. It creates an object which you can perform certain actions on. So let's take a look at all this and see if we can't get some of it to work. Okay. I'm just going to quickly throw our movie store database into my local Jupyter instance. There we go. And let's start up a new Python 3 notebook. Good. So, first thing, of course, that we have to do is we have to import SQLite 3. Next, we establish our database file handle, db is equal to sqlite3.connect. And of course, the name of our database is moviestore.db. And of course, when we are finished, we wish to close the database. Now, we create a cursor, db.cursor. We execute a command. I'm going to leave that blank for now. Then we want to print cursor.fetch1 and print cursor.fetch_all. So the interesting thing about this is that your string that you're using here to structure your SQL queries is a string in the most general sense in Python. So you can actually use all of the tools and techniques available to Python in order to generate a bunch of things, or format your queries in specific ways, or do all kinds of interesting things. You could even write a class that simplifies the generation of the query string so that all you have to ask for is the field names, and it will automatically create the select from this, that, the other. All of that nice stuff. So let's make our SQL query as something basic. Select star from movies. SQL query. And let's see if this works. Ho-ho! There we go. So this first one is the running of fetch1, right? So we have the first entry. If we ask for a bunch of fetch1s, you can see we actually get a bunch of these fetches out again. So what we're doing, it's very similar to the difference between read line and read, because read line will get one line, then the cursor moves to the next line, you read that line, etc., etc., etc. So fetch1 operates like read line, and fetch all operates like read. Notice, however, first of all, notice that everything has been formatted in tuples. And second of all, notice that when you fetch all, what it's doing is it's taking all of the tuples that constitute all of the different data, and it is putting them all into a single list. So that's how you would be executing your SQL queries. So, and if you want to if you want to do something more complicated, order by movie ID or something like that. It already is. Descending. There you go. And then it actually changes. Can you write to a new DB file in Python? Yes, I imagine you can. Yeah, let's try it. Thank you for the suggestion. So let's db.open. Let's create a new file. Call it new database.database. Close it afterwards. And basically, you want to copy all of this stuff, right? And let's create a new table in there. And I'm just going to take a look up in the slides to see what the syntax was for creating a table. Let's see. So, create table A, contains fields A, integer, B, text, C, real. There we go. Then, of course, we should actually test this to make sure that it works. Query 2, we will have we'll insert some data into it. So insert into table A, B, C, values. Incidentally, those don't have to be on different lines. They can be on the same line. What's important is the semicolon. The semicolon indicates the end of a line, even if they're across multiple. Let me rephrase. The semicolon indicates the end of a command, even if that command spans multiple lines. So values will be 1, blue, 4.7. There we go. And then SQL Query 3 is select star from table A. There we go. So we'll execute all 3 of these commands. Then we will print our fetchings. There we go. And let's see if this works. I have an invalid syntax. Did I forget? Oh, yes I did. Remember, in Python, if you want to put quotes inside of quotes, you can use whatever quotes you didn't use. Fortunately, in SQL, you definitely can use either single or double quotes to indicate strings the same way that you can in Python. Attribute error. Oh, did I probably used the wrong term. I think it's connect, not open. Object has no attribute, connect. Well, oh, yeah, okay. Silly me. There we go. And there you go. So yes, And if we go to the file system and take a look in here, you will see that new database has been, in fact, created, which is cool. Can we take a look and see what's inside? Error. Not UTF encoded. Interesting. Very strange. At any rate, the thing with these databases is that usually they are encoded such that they can't really be read unless you're using SQL, unless you're using a querying language to acquire the data that's inside of it. So, trying to view a database file, like you need a dedicated database viewing application, probably Microsoft Access or something like that. You could make it work. But anyway, yeah. So that's how you hook all of this stuff up to Python. Are there any questions about that? Okay. So another interesting point about the cur object, the cursor object that we create here, post execution, is that it is also of an iterable data type in the same way that the CSV reader produces something that's of the iterable data type. Therefore, you can use for loops to get all of the different rows inside of cursor object. So for row in cur, print row, and oh, it already exists. Haha. Then we can just comment that out. Comment that out. There we go. Interesting. Well, at any rate, I'll probably, is this one? There we go. In this particular instance, if you want to do for row in cur, print row, you can see that it, again, the only difference here is that it is printing out each row individually without it all being in a single list. Question: could you have also done that with the open syntax? So, general purpose file opening is a different matter. You can definitely open any type of file that you want using open. There's no actual restriction on the, Python doesn't look at the file extension of the thing you're trying to open and say, no, that's a thing you shouldn't open that way, and say, no, it doesn't do that. With open is general purpose and works on all file formats. The question is, are you interacting with the data in the way that the data intends to be interacted with? So if we were to open a database using the regular file, first of all, we don't know whether the data is encrypted. And if it's encrypted, we're going to get junk back. Also, we don't know how this data is being encoded. We already received a message from Jupyter when we tried to open this that the file is not UTF-8 encoded. So the question is, if it's not UTF-8 encoded, how is it being encoded? Problem, right? So if it is a database and if the preferred way to interact with a database is via the database methods that are contained in the SQLite 3 package as provided in that module, then it is wise of us to do that. It's kind of like you could read a CSV file without using CSV Reader. Like you could do the parsing yourself. It's just more work that you don't have to do, so you might as well just use the libraries that are being provided to you. But hopefully that answers your question. So yes, we could have done this with a regular open, but it would have taken a lot more time, and we would not have been able to execute SQL queries directly. Like we would have to reconstruct the functionality of the SQL query that we wanted to do from scratch. Whereas here, we get to leverage all of the wonderful availability and the wonderful well-orderedness of SQL queries from within Python. Hopefully that answers your question. So, with respect to our databases, we can add an additional line here. db.rowFactory is equal to SQLite.row. This occurs after the creation of the database object, but before the creation of the cursor. I don't know why it's called rowFactory. SQLite 3.row. What happens here is we get to formatting the data in a slightly different manner. So in this respect, the row objects are you can search them like dictionaries by using keys. So there you go, right? In the same way that you can look up the entry in a dictionary by knowing what the key value is, you're able to look up the value of a particular field in a particular record by using the name of that field. But you have to add this line which tells the database object what it's considering a row to be. So there you go. We can also, as I demonstrated, we can also add or create, insert or create table, or perform general SQL queries from within Python. But we can also insert values from Python variables into SQL queries. So what this example is showing us is that we've got M, T, G, and R, which are all variables that we have in Python. Movie number 17, title Beauty and the Beast, G, animation, musical comedy, and R is, although I would think that the genre of romance should be in there somewhere, come on guys, and then our rating is G. If we have these this placeholder value syntax, then we can in fact pop these guys over into this automatically. And this has nothing to do with SQL queries. In fact, this is something that Python can do generally. Let me demonstrate. So, or maybe it is. But I think you can do the same thing in print. Let's take a look for a moment here. So, insert into movies, values, question mark, question mark, question mark, question mark. And our next argument will be, well, let's just do the whole thing, eh? Oh. MTGR. Well, I guess that is specific to execute then. Never mind. I'm dumb. I was saying dumb things. That doesn't work with print. It just works with execute. So if we let's comment out this query that we've got here, and let's throw this stuff in here. We'll copy this thing that we want to execute, replace that there, and then we'll just see what the state of the database is prior or post this operation. Select star from movies. There we go. You can see that Beauty and the Beast has been added to the list of things that are in the database. So what it does is these question marks are also acting as placeholders. They're kind of similar to wildcard values, but what's happening is they are being bound to these values that are contained in this tuple. So when execute executes, it looks for the question mark character and populates those spaces with the string conversions of all of these things that have been given to it in the second argument, which is kind of cool. Makes it a lot more general. So, for example, rather than having to type everything out a second time, we can just, add stuff here. So what's a movie? Star Wars. Western. Rating, PG. Because people get sliced in half in that one, so probably PG-13. There we go. And as you can see, Star Wars is now added to the list. The one thing that you may notice, however, is that Star Wars is added to the list, but Beauty and the Beast has not been. So what gives? Well, we've actually been forgetting to save everything. There is a special command, cursor.commit, that actually saves these changes that you're making to the database to the database. So if we run, we then have a attribute error. It has no commit attribute. Are we sure about that? Have I misspelled it? Interesting. It's possible that they've changed what that's called. Anyway, I'll look into it. So, this is all good. So let's talk some theoretical stuff again. So you'll notice that up to this point, we have been operating primarily on one table. It's important to understand how to use a single table before you start to learn how to use multiple tables. So, this is not necessarily an accurate representation of the uses of databases, though. Databases will very often have multiple tables. So, let's suppose that we want to keep track of which customer rented which video in our movie rental store example. We'll need two additional tables. Number one, a table of customers, and number two, a table of rentals, which keeps track of the relationship between customers and movies, i.e., it keeps track of which movies have been rented by which customers. So, the manner in which we will create our the manner in which we create our customer table is very similar to the manner in which we create our movie table. We have fewer fields going on here, but I'll spare you the details of having this actually entered. We've got unique customer IDs, we've got customer names, we've got addresses, and all of that stuff. Then, we have the customer movie relationship database. So, the schema for this particular database is we have customer ID, we have movie ID, we have a date rented, and a date due. So, notice customer ID and movie ID, these are the same field names as the other two tables. Well, movie ID contains a movie, and customer ID contains a customer. Where am I here? There we go. So yeah, the purpose of that is so that we use the field identification, the field tags, as a way of cross-referencing the customer IDs and movie IDs in order to be able to determine various things about who has what, etc. So, the problem that we run into is that if we do a select operation on the rentals table, we will only get the customer ID and not the customer's name, and we won't get any information about the movie either. Naively, we would have to do an extra select to look up each customer one at a time, which sounds tedious and terrible. However, in structured query language, we have a way to do all of this at once. And what it essentially comes down to is this. We are creating a new constraint, and we are selecting from multiple tables. So, we have from all, or select all from both rentals and customers, where customers.customerID is equal to rentals.customerID. So, what happens is that we get the following, and we'll execute this code next time. We're kind of beginning to run short of time today, but this is what you get. You get the customer ID, the movie ID, the date rented, the due date, the name, and the address, which has been put together. It's as if we had a single table with the rows from each table joined together when they match the customer ID field. This is also called a join operation or an inner join. Cool. So, I think that we'll leave it there for today. I will stay on the line for a couple of minutes if anybody has any questions about anything that's gone on before that. But aside from that, yeah, that's databases mostly. Please feel free to ask any questions, but aside from that, I think we're done, folks. So I have a question about the test that's coming up. Will test 3 be marked the same as an assignment using an auto grader? Yes. Yes, it will. We are going to be leveraging the technological tools available to us in order to do things as efficiently as possible, which means that, yes, we will be using auto-grader tests for test 3. Okay, I think that's it, folks. Thank you very much, and I'll see you guys on Monday.